In this video, we'll be looking at the lateral calibration of the Reveal software. And you'll notice that all the plots have X and Y lateral resolution noted, shown here. That's in the synthetic fringes, the phase map, and shown here in the phase map, and even in the frame data, shown here, and in the diagnostics. The only situation where there are no lateral calibrations are in the 3D plot. So there are several ways to adjust the pixel size, and the first way we'll show is with the calibrator, which you can either open here, pixel calibration by the icon, or going over to the services, auxiliary, and then you have the pixel run pixel calibration, so you can do that here. So when you open it, there's several choices you can have for the data you want to look at. In this case, we're looking at the Zernike Fit data array, but you could also look at, let's say, the spike filter, or let's just say phase averaging. So there's a number of different ways, and we'll just use the Zernike data array. On the window to the right is this ruler, which you can set anywhere in the plot. And if you click set diameter and you have a circular part, it'll actually pick up the best fit circle here. And let's say you want to make the length of that, which would be your part size, 50 millimeters. You can set that here to 50. And then clicking return, you'll see that it'll now be set in your pixel size to give you 50 millimeters. And you can either set it to update all pixels going into the future as this 50 millimeter aperture, such as if you're doing a series of parts, or you can leave it off as I have it here, saying that this is one part you're measuring. So when you click OK, all the plots now are adjusting to 50 millimeters, as you see shown here. Another instance you want to look at is with the lateral calibration shown in this part up here. You open that, and right now we're in millimeters, but you can also change the inches, and you'll see the 50 millimeters changes to nearly 2 inches. So that's a direct conversion. Nothing else needs to be done. So going back to the millimeter, we'll see it's back to 50. Another method to change the pixel size is to go to the analysis tools and then open up the measurement configuration as shown here. And there's pixel size, and this pixel size directly relates to what was in the pixel calibrator. And you can set this as you wish. Let's just change this to a different value, let's say 0.3 millimeters, and now the part size has changed immediately to a larger size. And finally, there's a method to calibrate the aperture, and in this case, let's say you had a flat and you knew exactly what the part size was, or you had a transmission sphere and you were overfilling it so you knew again what the part size was by the outside edge. You could just directly set that, and you could use here the pixel calibration. We're going to set this to some other number, let's say 60 millimeters, and then we're going to say use that calibration, and now you see our size change to 60 millimeters. Now, one thing to notice is when you are using this calibration, it automatically adjusts it, but it overrides all the other previous calibrations. So this is the master in a sense. And even when you turn it off, you'll notice it stays the same. So if you wanted to go back and recalibrate, you need to turn this off, go back to your pixel calibration, change this size to something other, let's say back to 30. It changes the pixel size, you click OK, and now we're back to 30.